Let's go ahead and do this problem. If you haven't tried it on your own, please do so. Again, these you do videos where I explain is just so that you can check and see how you've done it and if you've done it in the same way I have. All right, we want to find the area between y equals x squared minus 18 and y equals negative x to the third plus 4 on the interval from -1 to 2. I'm going to graph these. By the way, graphing is not the only way you can check which curve is on top. You could have also plugged in a bunch of values between -1 and 2 and figured out which curve is on top. But I'm going to graph it because I like graphing a little bit better. It's a little bit easier to do than plugging in lots and lots of values. I have just typed in the graphs of these two functions into Desmos. Obviously, this is not the greatest window to see, so I'm going to zoom out a little bit. I can see a little bit better now. Y equals x squared minus 18 is the curve in purple. Y equals negative x cubed plus 4 is the curve in black. The interval that we were looking for, well, that started at -1 and went over to 2, I believe. Between -1 and 2, you can see the black curve is above the purple. So in here, the black curve is above the purple. And so that means the negative x cubed plus 4 is going to be on top. That's going to be my f of x. And the x squared minus 18 is going to be on bottom. That's going to be my g of x. Let's set up the integral. The interval goes from -1 to 2. We're going to do an f minus g inside. Like I said, the top function on that section is negative x cubed plus 4. And we're going to be subtracting the bottom function, which is x squared minus 18. At least it's x squared minus 18 over the interval that we're looking at. In other words, between -1 and 2. I like to clean things up. I like to rewrite this integration by combining like terms, and I typically put things in descending order. I would have a negative x to the third, a minus x squared when I distribute the minus sign, and then my constant in my original function is going to be 4 minus a negative 18. So that is going to be plus 22. When I take the antiderivative of this function here, I have to raise the x. This is a polynomial function. So I raise the exponent by 1 and then divide by that new exponent. My first term is going to be -1/4 x to the 4th. My second term is going to be -1/3 x to the 3rd power. My third term is going to be 22x. I could add on any constant that I want. I will make it easy on myself and add on a constant of 0. This is one antiderivative that we can use. The others would just be differing by some sort of constant that we would have added at the end. We're going to plug in a 2 into this function. Then we'll plug in a -1 into this function, and we will simplify. Let's plug in 2 first. That gives me -1/4, 2 to the 4th, minus 1/3, 2 to the 3rd, plus 22 times 2. In other words, every time I see an x, I replace it with the number 2. Then we're going to subtract off what we get when we plug in -1 into the function. So that I don't, well, I will. I'll run out of room. That's fine. So everywhere I see an x, I replace it with -1. I don't think I can expand my margins right here enough to get it back on the page. No, couldn't do it. So there it is. It looks a little bit ugly. Maybe this will look a little bit less ugly if I do something like this. Oh, I don't know if that helped or not. Maybe that hurt the look of it, but it's just the look of it. Let's go ahead and plug 2 into the first part. Type this into your calculator, and then we'll plug -1 into the second part. We'll type that into our calculator. I have already done that. I've already plugged in the values. When I plug in a value of 2, I end up with 37 1/3. When I plug in a value of -1, I ended up with a -21 11/12. -21 11/12. Notice that in this case, we're going to be subtracting a negative. That's perfectly fine. So 37 1/3. Subtracting a negative would be like adding 21 11/12. When I combine all of that, I end up with a 59 1/4, or 59.25 exactly. That means the area that I saw graphed out by these two functions on this interval is actually 59 1/4. That's a pretty interesting problem there.